So I'm starting GIS, which stands for Geographic Information System, a very important subunit in computer applications too. I'll also be handling artificial intelligence, which is also a very important subunit, especially in current times. AI is coming and is going to take over most of the things we do. So you as an ICT person, you have to embrace AI in what you do. You have to embrace it. It's going to propel you and even make you to be in a position to do what you do in a much and a better way. If you're used to handling 10 clients every 1 hour, with AI you will be in a position to handle very many people at a go. So these are GIS and AI. I'll be going through them as the introduction to what you later can do in future. So I'll start with the GIS, Graphic Information System. I'll discuss a few things about it, how it is applied. Then later on I'll look at AI. So we can start with the definition of a graphic information system. It's a computer system that is meant to capture, store, analyze, manage, manipulate data that is of spatial kind, data that is of a graphical kind of graphical area. It is mostly used for creating maps. So you can also say it's a computer-based tool for mapping and analyzing stuff that is in an environment, like here on Earth now. So it's more of guiding you as a person who wants to come up with a map of an area. So it makes it easy for you to create maps. So and be in a position to also do analysis, being in a position to make decisions of an area by looking at a system that is of geographic kind, the area you are interested in. So we'll go to components of the GIS. So one is the hardware. These are the physical or tangible parts of the GIS. In our case now, the graphic information system. So you will have to have the physical parts. That's the computer, desktops, laptops, anything, any gadget, smartphone, tablets, any tangible thing is also a key part of a component that should be there. The next component is the software. These are instructions or programs that are to guide you in analyzing your data, storing, and being in a position to display your output. So software comes in components also. So one of course is the graphical user interface called GUI, that brings you icons, symbols, shapes that you can be using to manipulate and have your way of using that application with the mouse, or with pointing with the mouse, or moving with the keys and the like. Also another component of the software part other than GUI is the DBMS, database management system, that is for managing the data that you've collected about a geographical area. Then you also need to have tools, to be good with the tools that are for maybe queries, analyzing, visualizing, tools for manipulating the input data. So tools for generating reports. Those are the components under software. Software is a component, just like we have the hardware. So the hardware being the physical part, software is more of the instructions or the programs part. Another component is the data. This is now the data you are collecting or you are capturing if it is visual. So this data about an area, a spatial or an area, is what you convert into digital format. You convert it into digital format. The data could be from photographs, data could be from images, data could be from documents, data could be from maps that have been done before. So this data is what you capture with for the GIS now to be able to process. Another component is the person, the people using that system. So these are the technical guys who are capturing data, feeding the data, generating reports, manipulating this data. So people or the persons or the user using the GIS is also part of the components. Another component of a GIS is the methods, or another word is the operations you are doing, the practices you are doing. So the rules you are following, what model are you using, what are the operations, what are the steps or the practices you are doing. Those are the components of GIS. So I started by saying that its components: one is the hardware, two, software, three, data, four, the people, and five, the methods. Let's also look at the importance of GIS. Why is it important? GIS is important because it helps you in explaining events. So it helps you to explain reasons as to why certain things happen in an area, what could be causing this and that to happen, why certain areas are flooding, why certain areas are having landslides, why certain areas are very hot, why certain areas are having this kind of soil, why certain areas are having this kind of temperature and the like. Number two, helps in identifying communities that are at risk. So it helps you to identify those areas that are maybe in danger of experiencing natural events like fire, flooding and the like, high temperatures, very cold temperatures and the like. Another importance of GIS is predicting, helping you to predict outcomes. So you're able to predict by studying the clouds, by studying the speed of wind. You're able to predict outcomes, if it is normal or not normal. Another thing, it helps you in planning and coming up with strategies that can assist you in mitigating challenges. So when you have a system that is geographic in nature, you're able to come up with ways you can avoid serious effects on the people around that area by alerting them and maybe by notifying them of the solutions they need to have. If it is an issue that concerns pests, maybe some disease, you're able to look for ways you can mitigate, or some viruses, some pests that are affecting farmers. So you're able to come up with strategies. Another one is it helps you in solving problems and improving productivity of an area. So you can advise farmers on what to do to avoid certain attacks from insects and the like. So you can advise them on ways they can apply to avoid losing or their crop and the like. It also helps you in making decisions. GIS system will also improve how organizations are able to integrate with the community, how organizations are able to even share communication, share information between each other on ways they can improve and make life better for the environment and the people in this environment. So departments can also share information, share resources, share expertise and the like when they're using a GIS. to study the environment. What I said earlier, the sound, the soil type, wind, speed of the wind, clouds, rocks, temperatures, all these things, how slopey an area is, type of trees, type of plants to work on. All these fall under GIS. You study an environment and come up with policies, strategies that can help in decision making and being able to provide expertise, advice to everyone in that area. Importance of GIS to the environment. One, it helps companies like electric companies to know where they can create bricks for their circuits. It also helps communication companies to know the place they can install masts, which is the best position, which is the highest level in an area, which part is maybe at the lower end, that may experience network challenges. So all this information is used to make these communication companies to know where they will install their gadgets to best be in a position to serve as many customers as possible. It also helps real estate companies to identify the areas they can go and do some development. They can study an area, study the population, study their needs, and come up with ways and the type of clients they maybe can build houses for. And another thing, it also helps in research in the agricultural sector. They can study the soil, study the climate, do research on crops, and then be in a position to advise the farmers in that area. It also helps in better management of natural resources in an area, how best to protect forest, ways to protect the natural resources in an area. Another thing, it helps in communication and coordination in case there is an emergency. So a GIS system is able to give you suggestions of what can happen and what is the best way to solve that challenge. We also have GIS data types. So there are two main data types in GIS. One is spatial data about an area, space. It describes the absolute relative location of the geographical features. So it's called spatial data. The absolute or relative location of geographical features, what an area maybe has, is what we call spatial data. Another type of data type in GIS is attribute data, which is also called tabular data. This describes the characteristics of that spatial feature that you found in that area, the characteristics of that you can measure, that you can be quantitatively done and even qualitatively analyzed about that characteristic of a spatial feature in an area. So if it is a forest, you can actually say this forest has this distance, it's this long, this is how it is, it's on this side, is it slopey, is it flat, is it on a hill, what meters, trees are what kind, which trees are most dominant in this area, why that is the case. So it's an attribute data that you are now, if you are giving characteristics of a feature you've found about a geographical area. So those are the two data types: spatial data and tabular data or attribute data. We also have layers or subsystems in GIS. One layer is the data input layer. This data could be from hard copies of already existing maps. It could also be soft copies Data could also be photographs that are either hard or soft. Data could be survey documents that are either hard copy or soft copies. Data could be reports that are either soft copies or hard, so it will depend with what you're using, but that level is called the data input layer or subsystem. The second layer is the data storage or retrieval layer. So this area is the layer that you organize your data. You put the data in a way that you'll easily be able to retrieve in case you need it. There's also the layer that you do analysis, you do updates in ways of maintaining that data. You look for ways of how you can maintain that data. Then number 3 is data manipulation and analysis layer. So this has the procedures you will follow so that you can be in a position to generate the output that is making sense and can be used for decision making. It's called the data manipulation and analysis layer. Then the fourth layer is the data output layer. So this is now when you display the reports, the results you've processed. Reports could be tabular kind, you are now generating them. And the reports could be maps that are automatic from the system. It's now the end product of what has been processed by the Geographic Information system. So those are the layers: data input for feeding data, data storage and retrieval layer, where you kind of put your data in a way you will easily be able to retrieve and maintain and even do updates. Then the third layer is the data manipulation layer or data analysis layer, and then the last one is the data output layer. Those are the 4 layers of GIS subsystem. Let's also look at data models. So data models are 2. So in GIS, you either have your data in vector mode model or raster model. So the spatial features, the features I've said of an environment can either be either in vector or in raster data model. This is how you store, you structure, you analyze, you do your processing of the data you have. So in vector data model, you use X and Y coordinates to explain something, where you create something that looks like a graph. There's X and Y features. So anything you're explaining is falling under points in the X and Y coordinates or lines or an area you've highlighted on the like a bar chart kind. It's called vector data model style of displaying or working on your data. Features are distinct. They are like discrete over the spaces that you are interested in. Then number 2 is the raster data model. This works like a grid where you have multiple lines that are vertical and others that are horizontal. We call that a grid. That style of displaying, working with data is called the raster data model. So it's the special features are explained in form like a cell, kind like the way Excel has rows and columns. So each cell is like a grid where you can have a value and the characteristics of the special features are in that particular location. So it work with the grid. Those are the 2 data models in GIS, Graphic Information System. So application applied in various fields. One is in mapping, like I've mentioned so many times in this tutorial. One is in navigation, in the idea of creating Google Maps, that idea of having Google Maps. is as a result of, it's an example of a graphic information system. Another area it's used is applied in analyzing accidents, hot spots in a road. Why there are so many accidents in an area? Is the place sloppy? Has the design of the road been done as it should? What kind of road is it? So all these are features that you work with when you're analyzing. So they apply that in studying how areas that are prone to accidents, like a road that has a hotspot, why the reason as to why that is happening, and the ways you can maybe design that road and be in a position to assist people. Environmental impacts analysis, so anything happening in the environment, you can use GIS to understand why, and areas that can be that need some improvement. Disaster management and mitigation, flood damage estimates, managing of pest control, banking, so where to open the branches. You study the population, get to know the products in that area, which are the best crops to grow in that area, all these. So the application of GIS is very, very applicable in our day-to-day operations. So the agricultural sector will use it to study soil, rock, pests. People in transport in the transport industry will also use GIS to study how they can plan their transport services, areas they can open up routes for their company. So urban planning, all these things are at GIS. The best places to open branches for the dairy industry, all these are under, you study an environment, including the people in that area, to know why they are behaving as they are behaving, and if there are challenges, which are these challenges, and how you can assist them. Even telecommunication companies, they get to apply so much of GIS to know how they can best utilize their network coverage in an area. So they may look for a high position to position their equipments, position a branch, the best spot to position a branch of a company will use GIS. All these are even natural resources, wildlife. They will look for the best areas to introduce certain government agencies to assist an area. Those are the application fields that we have GIS. Then we have GIS processes or tasks. So therefore, one is the input process. What I said earlier, you feed data into the system that should be converted into a digital format that can easily be manipulated and utilized well in the system. Another one is after feeding input process, you have to now do manipulation of the data. You transform that data to a way that can be, the system can accept and be in a position to use. Then the third process is management of that data. So here you use a DBMS to store, manage, organize your data, manipulate. You use a database management information system. And then the last process is more of now generating reports, asking the system a question. Then it analyzes that data and gives you an answer. So you may ask the system, what's the distance between this and this? It does the processing and it gives you an answer. What is the dominant soil in this area? What is the common pests in this area? So why is this happening and that happening? So you ask the system something, it does the processing and gives you an answer. This could be using queries. So after input has happened of the data and the manipulation has happened and the management by use of a DBMS, you now can analyze and generate reports that can assist you in making decisions. That's what we mean by GIS. Then we have something else called numerical and categorical data in GIS. So here in GIS we have machine learning, where it's more of cases where data you are dealing with is in two. So we have numerical data, which could be data that is having whole numbers or data that can be having decimal points. It's called numerical data. Then you have number two, categorical data. So categorical data is more of everything else that isn't you cannot anything else, and in particular discrete or labeled groups that don't provide much direction as to how data should be manipulated. It's called categorical data. Everything else other than the figures and the numbers that could either be whole numbers or decimal points, which you call numerical data. This other data that isn't in number form is called categorical data. Those are the data that is in line with when we talk of numerical and categorical data in GIS. So in machine learning, data is in two when it comes to GIS, either figures or this other data that is not in figures. Something else we can look at is precision errors in GIS. So what is precision in GIS? This is a level of measurement of the exactness or description of something in GIS, like the exact measurement of that could be in meters, inches. So how you are describing that data, the exact description of the data in terms of measurable units, like meters, feet, and is what we call precision. So when we talk of precision errors, that means when there is an error because of maybe how the surveyor maybe recorded, where maybe the surveyor made a mistake. So it's called precision error. An error that makes what you have not to be accurate. So maybe at the time of gathering, it wasn't done accurately. It's what we call precision errors or precise errors. That's all concerning introduction to GIS. So I'll now go to introduction to artificial intelligence, which is referred to as AI. I'll also explain a few things about it as introduction, and then later on you can do more concerning this. Is a field that is very, very wide, and it's where we are now heading to. The world is moving towards AI. So if you're into any field, any career, this is a field that you have to look for a way of utilizing it, so that you become more productive and be more competitive in these current times. So artificial intelligence is the ability of a computer or a machine to behave like human beings, or a way of making a gadget or a machine to do tasks that the normal human being does. So it does some simulation to simulate human intelligence. This is what we call artificial intelligence. the ability of a gadget or a computer or a robot or a machine to do tasks that are usually done by humans, to simulate human intelligence. Is what we refer to as AI. AI has a few categories. So we have robotics, we have cognitive science or intellectual thinking, and we have natural interface applications. These are categories of artificial intelligence: robotics, cognitive science, also referred to as intellectual thinking, and natural interface applications. These natural interface applications now include speech, voice recognition, and VR, virtual reality. These three, speech, voice recognition, and virtual reality, falls under natural interface applications. So we have like robotics. Robotics is a field of engineering that is multidisciplinary, that deals with how you design, operate, construct, and create robots. So it's what we refer to as robotics, a field of engineering and science that deals with the design, creation, and operations using robots. So robots are programmable machines that are programmed to carry out tasks so that they can maybe assist or supplement human actions, or mimic, copy, and behave like human, or supplement what the human is doing, or assist. They're called robots, programmable machines. We can look at where they are applied. Worldwide, robots are very common in some areas of the world. Some areas they use them for security. They are used as security guards, gadgets that are used as security guards to detect thieves or intrusion into an area. Robotics are also applicable to space exploration. People going to space, astronauts going to space, they can use robots to help them collect samples, study deep space where it is maybe challenging for humans to get to. Robotics are also used in entertainment. So now we have cases where actors can be machines that can they can even be, a machine can be handling a camera. A machine could be providing special effects on a movie. So these are, they are common in entertainment industry. So what actors cannot do, a machine can assist in propelling, maybe moving them from one position to another, lifting them up and the like. We also have healthcare. So we have machines that are being created to do operations. Cancer patients sometimes go through therapy. So a robot can be used to do the therapy to patients, do operations. They are like assisting doctors in performing some tasks and analyzing data, and being in a position to even assist in making decisions on how to treat patients. Robotics are also applied in underwater exploration. So those areas that are tough or challenging for humans to get to because of the pressure and the like, robots can be used to go deep into those areas. Robotics are also used in manufacturing, especially lifting and carrying heavy stuff, joining very heavy stuff. Robots can be used in doing that, in welding, assembly plants for vehicles, assembly plants for motorbikes. So That's manufacturing, which is very common. Robotics can also be used in military. So we have drones that can be moved around to monitor, drones that can attack nowadays, drones that can do surveillance. So robotics are also used in customer service. So you could be calling a company and you're interacting with a robot or a chatbot. So these are areas that robotics is applied. The other thing we did we mentioned earlier was cognitive science. These are a field that seeks to understand the nature of the mind and intelligence, or how the brain processes information, how we perceive or think or learn. So it's called cognitive science, an interdisciplinary field that seeks to understand the nature of the mind and the intelligence, to study how the brain maybe processes information, how we think, how we learn, so that you can be able to process and how you even behave. So that's what we call cognitive science. So how you are processing information, how you are behaving, that idea of studying how the mind operates is what we call cognitive science. Another thing, voice or speaker recognition, is the ability of a machine to receive and interpret voice commands or spoken commands. So it's able to recognize your voice and be in a position to interpret. So you don't need to press buttons. It's able to listen, and as you talk, it captures what you're saying. So you like say close the door, it closes the door. So you give it commands verbally. It's called a voice recognition. If it's speaking back to you, then it's also able to answer you. It's called a speaker recognition, by giving you responses. So advantages of these ones, voice recognition, it helps to increase productivity in businesses, so especially healthcare. So it's able to listen to heart vibrations, noises you are making, requests you are giving it verbally, and be in a position to give you suggestions or answers. It also captures speech faster than you can type. So the idea of talking to a machine becomes faster if you compare it to a case where you are maybe typing. Someone else who is typing would be slower than you who is engaging your machine verbally. Another thing, you can use text to speech in real time when you are dealing with a gadget that has these features. It's also able to spell words and be in a position to even give you ways of how you can pronounce. So it can assist people who have challenges speaking and or sight. So if you have a challenge speaking, the system can assist you back and assist you in talking. So you can be giving it signals and it talks to other people on your behalf. If you also have sight issues, it can also assist you in monitoring the environment for you and giving you signals of what is ahead of you. So sight recognition, can assist people with sight issues. Then we have VR, which is virtual reality. This is an experience that is virtual, an experience that is simulated to appear like the real world, but it isn't. So a person using virtual reality equipment will appear to be in another world that isn't real, but appears to be real. and is able to interact with that world using the sensors. So like someone wearing goggles, that are VR goggles, they're able to get into another simulated environment where they could be watching a movie, could be fighting virtually, could be driving, could be watching some animation. It's called a VR. It's also an element in artificial intelligence. So you move around that world, that artificial world, and be in a position to interact with the items in that world, which isn't real. So application areas of VR include entertainment, like I'm saying, video games, education. You can wear goggles so that you can study. You can also be doing medical operations using that. Operating some human, but it's actually not real. Arts also get to use VR when they are learning engineering, when they are learning arts, when they are learning military stuff. Virtual reality can be used. Another area that virtual reality is used is in cinemas, just like in entertainment where you're working with video games. Cinemas can also give you VR goggles for you to watch the movie in that experience another kind that isn't the same as watching directly on a screen. So here you get to be in the environment where the movie is being acted on. It's also used in business for virtual meetings. You can have a virtual meeting where you are interacting with a machine, a world where there are experts that are maybe giving you advice. Applications of AI in a phone. So all those features we did earlier was in AI. So where it is applied, AI is applied in healthcare, where I had said earlier, diagnosis can be done on humans using AI to understand what they are having as a patient and be in a position to give recommendations of the cure that can be best or used to face that issue they are having, a health issue they're having. AI can also be used in business, where you can do some analytics on human relationships with the company and be in a position to uncover ways that you can better serve your customers. AI is also used in education, where educators can create exams online that can be automatically marked. The marks are automatically generated by AI. So this you can automate the grading, you can automate the questions. That is AI. AI is also used in finance. So you can collect data of your customers and be in a position to look for ways that you can provide the best suited product or service to the client in finance. AI is also used in law. It can be used to peruse through documents that are needed by the lawyer, so that they are able to come up with the pressing the points to emphasize on in the court by perusing through documents that could be bulky and tough for the normal human being to do. So it can assist in perusing through files and checking through the constitution to identify those areas that maybe have been violated. AI can be used to do that. AI can also be used in manufacturing to help in operations of carrying what I said earlier, lifting heavy stuff, doing very sensitive stuff in the manufacturing industry that maybe that requires accuracy, and something that would be tough for the normal human being to do. A robot or an AI equipment can easily be better to perform and serve your customers better in the manufacturing industry. AI is also used in banking, where you could be handling transactions that are very many in a bank. So AI can assist you in doing this better over the internet. So chatbots can be used to even do customer care services and awareness and giving information and answering questions in banking. AI can also be used in transportation, where you could be operating traffic using AI, predict flight delays using AI, or predict shipping, making the ships safe, more efficient, serve customers well in the flights and even in our roads, in our seas, so or oceans. So you can easily be in a position to manage and operate and be productive in handling very many customers when you are working with AI in the transportation industry. Also, AI is also used in security, so companies can automate products and services to or be in a position to handle security issues in an area using AI, where alerts can be done via AI and automating the processes that are the procedures that are to be done when an alert comes, a security alert comes into an area. Advantages of AI: there is reduction of human error. AI is good for repetitive jobs. AI assists in decision making. AI doesn't get tired like human beings. AI can assist humans in taking risks. So all these are advantages of AI. They can provide digital assistance to help humans in doing what they are doing in the office, at home, wherever they are. However, we have challenges or disadvantages of AI. It is expensive. AI can make humans lazy. AI has no emotions. AI can cause unemployment. If you are not embracing AI, you may get displaced in the market because your competitors are maybe able to serve more clients than you. Your competitors are more efficient than you. So if they are using AI, so to be better placed in whatever career you are in, have your way of understanding AI and look for ways you can embrace it and make it work for you. That way you'll be able to grow and as a brand, as a person, as a company, and you'll be better placed to even serve customers better when you embrace AI. Then we have some terms we shall look at here in this AI section. So one is neural networks. Neural networks is a software that also include or hardware that works similar to the tasks performed by neurons of the brain of a person. So like deep learning and machine learning is part of AI. You may work with a neural network. I've said it's a system or software or hardware that works similar to tasks performed by neurons. So it gives a series of procedures that you follow to be in a position to recognize underlying relationships between data by mimicking the way the human mind operates. Is what we call neural networks. Machine learning, I had mentioned it earlier. So machine learning is more of a computer programs that can assess data and use it to learn. So it assesses data and learns from it. So it's an application in AI where the systems have the ability to automatically learn and improve from the experience they are undergoing without the need of being programmed every other time. So the data you have helps the machine to learn something from the data you are giving it. It's a concept in computer science where you use data algorithms to imitate how the human mind learns gradually. So from the data, the machine is programmed in a way it's able to learn a few things to make it more accurate next time by checking the data you are providing, and also the process. After it does some functions of some activities, what it later generates helps it to understand and improve next time. Then we have deep learning. Deep learning is under machine learning and artificial intelligence that imitates humans, how they gain knowledge. So it like imitates how the human understands with time. It's an element in data science which gives statistics and predictive modeling. It helps scientists who are tasked with collecting, analyzing, and interpreting large amounts of data. So deep learning will assist in going through this data and getting to learn about a certain field, more knowledge about a certain field. So it's like imitating how a human being would study and be in a position to learn something over a period of time. So it's more of statistics and predictive modeling of how humans gain knowledge. We also have natural language processing in AI, NLP. It's also under artificial intelligence in computer science that helps computers to understand how humans write and speak. So it's a concept that it's like mimicking how the human mind is able to speak and write. It involves a lot of unstructured data as a way of understanding how, trying to mimic how you talk and even how you write. That's what we call natural language, speaking and writing that is generated by AI, and how you reason and talk. Computer vision in AI is a field also in artificial intelligence, where machine learning and uses machine learning and neural networks to assist computers to learn how they can derive information from visuals, like from videos, how it can generate meaningful information from images and make recommendations of actions that can be taken. So it's a field in AI where you use what I said earlier, machine learning and neural networks. So I've explained neural networks in this same topic. So you kinda are training computer systems on how they can interpret images, videos, or data captured from any visual input gadget. It's for computer vision. Areas where it is applied, it's applied in metrology, core department, or industry. It's also used in assembly industries, used in for picking items and dropping them and positioning them well, and doing the screwing and the joining. It's also used in security for intruder detection. It's also used for checking quality assurance of products like aeroplanes, to get to know if everything is okay. So it's a field in AI called computer vision. So images can be captured to see if the correct and accurate angles have been designed on products and services to detect defects, assembly intruders. If they happen to step on something on an area, it's able to, the AI created is able to give feedback. Then you go to main parts of a robot. There are three. Robots have sensors, robots have effectors, and robots have something called the control system. So sensors are part of the robot that assists in gathering information about its environment. It's called sensors. It could be at the front, at the back, at the sides, at the top, at the bottom. And that part of a robot is called sensors. Helps in gathering information about its environment. Then we have effectors. These are parts of the robot that are meant to do the work the robot was created to do. They are called effectors. Then if it's meant to carry, meant to push, meant to move, means if the robot is meant to jump up, or the parts doing that are called effectors. Then the third part of the robot is the control system. That's like the brain of the robot. This part of the robot determines the behavior the robot will have at any particular time, as per the sensors, how programming has been done at the sensors, and also how programming has been done at the effectors. Those are the three main parts of the robot. Then we have types of search algorithms in AI. There are two: uninformed or blind search. This type of search does not contain any domain knowledge, such as closeness and the location of the goal of interest by the AI. So it's done without any prior information about the search space that is meant to do the searching. So initial state operators and test of the goal are not known. That's why it's called the blind search. Then we have number two, informed search. So this, or another name is experimental search. This type of search uses domain knowledge of the information about its environment and what it's meant to do, about the problem at hand, all these features about the information about the environment. That's why it's called informed search. Helps in coming up with solutions to complex problems that the uninformed search wouldn't do, because this informed search works with domain knowledge. Those are the two types of search algorithms in AI: uninformed, or blind search, and informed search. Another name is experimental search. Then we have emerging trends in AI. These are the examples of emerging trends. One is the Internet of Things, so a lot is going to happen there. Another one is cyber security. AI is going to go into cyber security. Another emerging trend in AI is hyper-automated business processes that are intelligent. Another emerging trend is AI will be used as a tool for global good in serving humans. So much is going to happen in AI. These are the examples of some of the emerging trends in AI. That's all for this topic. Thank you so much, and all the best.